In this mechanics video we have a 12 kilogram mass resting initially on a rough inclined plane where the coefficient of friction of the plane or slope is 1/4. This 12 kilogram mass is then acted upon by a constant force of 120 newtons acting at 30 degrees to the slope of the plane as shown in the diagram. The 12 kilogram mass will hence accelerate at a uniform rate up the slope. The slope is inclined at an angle of 40 degrees to the horizontal. The two tasks are to first A. calculate the acceleration of the object in meters per second squared, and B. is to calculate the time taken for the object to travel 250 centimeters up the slope in seconds. To do this, on the second diagram, all the forces and also component of forces will need to be shown on this diagram, and which will enable me to then show you how to calculate the acceleration and the time taken. As the 12 kilogram mass is being pulled up the slope, the frictional force, as shown by here, denoted by F, will be acting to oppose the direction of motion, so acting down the plane. There is also the weight of the 12 kilogram mass, which is 12g, which is acting vertically downwards. Now, in this type of question, I would always recommend that vertical weight is resolved into a component parallel to the plane and perpendicular to the plane. If the weight is resolved parallel to the plane, the component is acting in this direction of magnitude the weight, which is mass times gravity, so 12g, sine of the angle that the slope makes with the horizontal, in this case 40 degrees. The component of the weight acting perpendicular to the plane, i.e. in this direction, will be given by 12g cos 40 degrees. The next thing to do will be to put the normal reaction of the plane or slope acting on the 12 kilogram mass. This will also act perpendicular to the plane, but in this direction, and the normal reaction is normally given the capital letter R. The next thing to do is to resolve the pulling force up the slope into a vertical and horizontal component. This is done by creating a right angle triangle as shown here. The horizontal component will be acting in this direction, and since this line of the right angle triangle is the adjacent and the 120 newtons is in effect the hypotenuse, this will be cos. So this force here acting parallel to the plane but up the slope will be 120 cos 30 degrees, and the vertical component will be acting in this direction, will be the opposite angle to 30 and the hypotenuse, so it will be sine. So this vertical component will be 120 sine 30 degrees. So now this diagram is complete with all the forces and components of forces required to enable me to solve this particular problem. Now for part A, the first thing to do is resolve perpendicular to the plane, i.e. in this direction. Now this is a double arrow because the 12 kilogram mass is not moving perpendicular to the plane at all. So we have R acting upwards in that direction plus the vertical component of the 120 newtons acting perpendicular to the plane, which is 120 sine 30 degrees. And this will be balanced by the component of the weight acting perpendicular to the plane, which is 12g cos 40 degrees. So by rearranging this equation to make R the subject, we can find the normal reaction. So R equals 12 times. Now G has a value of 9.8 newtons per kilogram. So 12 times G, 9.8, cos 40 degrees, take away 120 sine 30 degrees. And this gives a normal reaction of magnitude 30.09 newtons. Having found the normal reaction, we can then use this equation here, F equals mu R. Now mu is the coefficient of friction. So the frictional force F will be a quarter times the normal reaction, which is 30.09, and that equals 7.52 newtons. So the frictional force acting down the plane is 7.52 newtons. Now the next thing to do is resolve parallel to the plane in this direction. The arrow is pointing in this direction because the 12 kilogram mass is being pulled up the slope in that direction. So the force acting parallel to the plane in that direction is it's 120 cos 30 degrees. Now we need to take away the other forces acting down the slope parallel to it. So we're going to take away 12 G sine 40 degrees and also take away the frictional force. Now this left hand side of this equation is the resultant force. And that's acting in this direction. And that's going to equal MA, since F equals MA. So now we have 120 cos 30 degrees minus 12 times G, so 12 times 9.8 sine 40 degrees minus the frictional force, which is 7.52 newtons, must equal the mass of the object, which is 12, times its acceleration, which is a. The left hand side, when you work it out, is 20.81, so that's going to equal 12a. Therefore the acceleration of the system is given by 20.81 over 12, which equals 1.734 meters per second squared, or to 3 significant figures, which is what you normally give the answer to. That'd be 1.73 meters per second squared. I've given this acceleration to initially 4 significant figures because I'm going to use this value in the next part of the calculation. So rounded to 3 significant figures, it's 1.73. So that's part A complete now. For part B, as I said at the outset, the 12 kilogram mass is initially at rest, so U equals 0 meters per second. We know the acceleration of the object is 1.734 meters per second squared. The distance, which is denoted by S, in meters is 2.5, and the time is what we need to find, so the time is the question mark. Now the SUVAT equation involving U, A, S and T is S equals UT plus a half AT squared. So substituting our values into this equation, S is 2.5, U is 0, so we've got that 2.5 equals a half times the acceleration, which is 1.734 t squared. So therefore t equals the square root of 2.5 times 2 all over 1.734, and this gives a time of 1.70 seconds to travel 2.5 meters up the slope. Hopefully you have found this video both interesting and informative. I will be creating quite a few more mechanics videos in the near future.